All right, I think we are recording now. Hello, everyone. I'm Nihal Hussain, and joining me online today is my colleague Hayder Al Rubaye. And today we both will present our work on stories from blogs, computational extraction, and visualization of narratives. So this work primarily focus upon presenting a tool that can help an analyst sift through blogs, and instead of directly reading those and reading each and every blog post, they should be able to just sift through them by looking at the narratives that are being um, pushed through those blog posts. So before I jump into the actual visualization of our narratives, I'll give you some background of the extraction algorithm that we use. This algorithm we had published in Text to Story 2020, and I'll give you a brief overview of what this algorithm is and how it works. I'll also give you some of the limitations of the visualization as well as the algorithm after the visualization that Heather goes over. So jumping ahead, so the algorithm of narrative extraction builds upon the premise that narrative text can be represented as directed graphs of semantic triplets. So by semantic triplets, I mean subject, verb, object sets. So basically, we look at phrases in the text where we have nouns and we have object and the verb phrases. So we like to say that a particular we like to identify those noun phrases to identify the actors that are in the blog post, and then we also like to identify the verb phrases to identify the actions associated with those actors. So the extraction algorithm, like I said before, published in Text to Story 2020, starts by the blog post, and it extracts all the entities in those blog posts. By entities, I mean here the named entities, example names of places, people, regions, organization, jobs, etc. So these are basically proper nouns in the blog post or names of something, some real world entity. And then once these entities are extracted from the blog post, these are fed as tokens into topic modeling. In the conventional method of we would feed all the words in the data set or in the blog post as tokens. Um, but for our approach, we only use entities. We have chosen this approach because in cases where we have an entity as in that has multiple words, example United States of America. So in a scenario like that, the when we go the traditional route, United States and America are considered as separate tokens, whereas when we go through the entity route, they're considered as one entity. So the complete word United States of America is considered as one entity instead of considering them as three different words. So once we have these entities as tokens, and once we run the topic modeling on top of them, we get our distribution of entities over topics as well as distribution of blog posts and topics. So for each blog post, we extract or we identify the topic that is the most representative in that particular blog post. For that representative topic, we identify the most representative entities from the topic modeling, from the topic entity distribution. For these entities that are the most dominant in the topic, we extract or we build only upon those. So this way, we only have the the most prominent entities of the most prominent topic in each blog post. So this way, we filter down the number of entities drastically. If we would have extracted the complete set of entities from a blog post, we would on an average get 25 to 30 entities, whereas going through this route gives us between 5 to 10 entities. Once we have these dominant entities from the blog post, we extract sentences where these exact entities are mentioned. This builds upon the idea that when in the text where the entity is mentioned, the text around that particular word or that entity speaks about that entity. So the theoretically we should be extracting few sentences before and after this particular entity. to extract the data around this entity. But for this algorithm, we only focus on the exact sentence that mentions that particular entity. So once we have this once we have the sentences, we do phrase extraction. In the phrase extraction, we focus on extracting noun phrases and verb phrases from the document, from the sentences here. To do that, we use POS tagging and chunking. By POS tagging, we identify the parts of speech in the sentences, we identify the noun and the verb parts, and then we use chunking to split the sentences into noun phrases and verb phrases. Once we have these phrases extracted, we then have, we had defined a grammar rule to extract exact narratives from these phrases that were extracted from the blogs. Once these narratives are extracted, we filter them and we rank them based on TF-IDF. So the narratives that are common in the corpus are ranked higher since they are popular narratives, and the narratives that are not very common, are not very dominant, have lower score, and they become fringe narratives in this corpus. To evaluate this algorithm, my co-author Kiran had used another data set that we had published at TextStory 2018. So this data set was about the European migrant crisis this was around 2014 to 2015. So this data set had more than 22 blogs. That from these blogs, we were able to extract more than 6,000 blog posts. And from these blog posts, we were able to extract more than 30,000 entities. At that time, we were using Alchemy API to extract these and identify these entities in the blog post. For these blog posts that we had identified that were about the European migrant crisis, we had a group of annotators in the lab that we had trained to label or extract or narratives for these blog posts. So for each blog post, these annotators provided us 5 narratives. The inter-annotator reliability between those annotators was 0.82. That indicates that it's really high and that we have almost perfect overlap between our annotators. Once we had the labeled narratives for the blog post, we ran our algorithm that I mentioned a few minutes ago, and the accuracy for this algorithm was 67%, indicating that the algorithm was able to extract around 67% of the narratives from the dataset. Before I jump into the limitations part of the study, I will let Hayder give you more details on the visualization part of this. Over to you, Hayder. Let me stop sharing so that you can share your screen.
All right. Greetings, everyone. My name is Hayder Rubaye, and I am pursuing PhD in information science, and I'm the second author of this paper. Continuing from Nihal's presentation, I will be talking about the visualization tool that we have developed with the Cosmos team. And as you can see, I have shared my screen. And this is what we came up with. This visualization is basically gets the data set from the backend team, like the narratives that have been extracted, and the keywords, the posts and all the information that's important. And this would be visualized in 4 main columns, as you can see over here. The first column is the keywords column, and the second column is the narratives, and the third column is the posts, and finally the last column is the preview of a post. So from these columns, that we can start with the keywords to the left, which has the list of the main extracted narratives. Sorry, the main extracted entities from the blogs, the blog posts. So as you can see over here, this list having Trump, China, Feds, America, etc. This list, if users just click onto one of the items, they would see the narratives that are related to the keyword, to this specific keyword that has been chosen. As you can see, all these narratives are related to China. If we click on a narrative, we can just see the related posts to the right in the post column. So as you can see, this is one of the posts, and that's another, and so on. So multiple posts are being displayed, have been displayed, and users can also click on to a post to view its preview, more details about the post. And as you can see over here, so after that, users can also they can also edit the narratives using the edit button over here. As you can see, they might have to correct a narrative, a specific narrative. So they might include like other words into this narrative. So China is the anything. And they can just accept those changes, and the narrative would be changed. Same thing for any other post. We can just change it. We can change it into people coming to China, and we can cancel the change also. Yeah, so these are the functions and that is in the narratives column and the post column. So after doing that, like users can also group multiple entities into one group. Let's say that I want America, Chinese, and BuzzFeed, for example, and we can group them by clicking this button. And as you can see over here, these are the entities, and this is a group made for those entities. Users can also click on to the group to see the narratives that are related to those entities. So over here, users might notice that BuzzFeed is the most prominent keyword because it's mentioned in every narrative over here. So BuzzFeed is mentioned the most, and we can just click on the narrative to see the list of each of the posts that are mentioning those narratives. So these are the posts that mentioned those narratives, and we can see the preview over here. And users can also delete a specific keyword if they don't want to. So let's say that I want to delete BuzzFeed news. Then they would get America and Chinese. If we click, we can see that right now America is the most dominant entity, and these are the narratives that are related to those two keywords. And these are the posts that are related to all of these of this narrative. And yeah, this concludes the visualization that we have been developing, and this tool is in development still. Like it's in development. It is not an end product, and we had so many bugs that we have to work on to solve.
Do you want to show, like, in case there is a keyword that is not part of the list, how can that be added?
Sure. So one of the things that I forgot to mention is that users can also search for a keyword and include it with the list of keywords that are on over here. So we might just search um, for anything else like virus. So as you can see over here, these are the entities that were discovered in the data set in those blogs. So let's pick, for example, the influenza, and these are the narratives that are related to the influenza entity. And we can also edit. Yeah, those are one of the bugs, but we can definitely do that, fix those bugs in the future. But anyways, as you can see, those are the narratives that are related to it. And this is the post that is related to that. And the Zika virus, for example, these are the posts that are related. And the MMR, we can just group, like, for example, the oh, this doesn't work. But anyways, yeah, this concludes that how the tool is working, and I hope that I've given a good introduction to the tool. Thank you so much.
Okay, um, so here are some of the limitations from the current study. So the narrative extraction algorithm that we have currently in the tool, it needs to be improved. The grammar rule that we use is very tailored to the current data set, that is the European migrant crisis data set. And it needs to be generalized for other studies as well as for a more diverse data set. Um, Moreover, the current study, like I said before, focuses only on the sentences in which the entity is present. So the complete blog post would be contributing to the overall discussion about the entity. But in this algorithm currently, we only focus on the exact sentence in which the entity was mentioned. So going forward, that needs to be addressed. We need to look at the complete blog post and add extract more information rather than just looking at the individual sentences. The third thing that I would like to explore as a future work is alternate methods to extract algorithms and extract narratives and build upon those. Coming to the visualization part is needs to be more extensively evaluated. Current evaluation set only has been some of the developers and the users of the block trackers tool. So these group of users are already well versed with the tool and they have an idea of how the tool was designed. So the learning curve for this group was not very high. Whereas if the tool was introduced to a completely new user, the learning curve might be completely different. So the evaluation of these narrative visualization tool that we presented needs to be more extensive. Apart from that, they are like Heather demonstrated, there are few bugs in the current visualization that are still fixing. We currently only display the top 5 narratives for each entity, whereas we could have a complete extensive list of all the entities for that all the narratives for that particular entity. Also, these we are building to improve on the current visualization based on the feedback of the users that we have. We're also trying to add more features like adding a network of entities. So currently, these visualization only gives you the list of entities and their narratives. Or maybe if you compound them, you could see the compound narratives around them. But we don't see the relationship between any two entities. So we are working on building a network of entities to see what entities are tightly connected together and what entities are more disjoint. So this way you could look at that semantic map and get sense of what's actually going on in the blogosphere. Thank you everyone for listening our presentation. We would like to acknowledge our funding organization. I would like to highlight that the studies and the opinion and the findings and the conclusions are our findings and visual as and only express our findings, and they do not necessarily reflect the views of the funding organizations. We on this slide, I have some of the link to the block trackers tool. This is the tool in which that Heather demonstrated. So in this tool, one of the module is the narrative extraction part. There are other modules in the tool that if you can go over and take a look at it. The other tools of the developed by the Cosmos Lab are also listed here. If you have any questions, you can visit the website and reach out to us. Thank you, everyone.